Section 3.4a, solving exponential and logarithmic equations. Day 1 here, we're going to focus only on exponential equations. Second half will be our focus of logarithmic equations. To solve an exponential equation, we're going to have a 3-step process. We want to isolate the exponential. So whatever has our variable in it, that is what we are going to get all by itself. Once the exponential is isolated, we're going to take the natural logarithm of both sides of the equation. That is going to then allow us to use our properties of logarithms to get that variable out of the exponent. Once we do that, then we just finish solving whatever equation that we have left. The only thing you need to make sure that you're doing is that you are giving both the exact solution in terms of whatever the logarithm is, as well as the decimal approximation that you're going to get from the calculator once you go ahead and you plug that in. So looking at letter A here, first step, we want to isolate the exponential. That means we get the exponential all by itself. In this case, e to the x is all by itself. So we can go right to the second step, which is to take the natural log of both sides. On the left side, natural log of e to the x. We know natural log and e cancel each other out. We're just left with the exponent. So x equals the natural log of 72. There's our exact solution. Plug that into your calculator. That will give you your decimal approximation, 4.277. And for your solutions, you need to be given both the exact one in terms of the logarithm as well as the decimal approximation. Letter B, isolate the exponential. So we want to get e to the 2x all by itself. Divide by 4. Once the exponential is isolated, take the natural log of both sides. On the left side, natural log and e once again cancel. Divide by 2. We get the natural log of 5/4 all over 2. We can plug that into our calculator to get the decimal approximation. Natural log of 5/4 divided by 2. Should get 0.112. There's our exact solution in terms of the logarithm as well as our decimal approximation. Quadratic equation. When you see something like this, it's no different than any other quadratic equation. You need to look to see if you can factor it. In this case, we're looking for numbers that multiply to be 2 and add to be -3. Those are -2 and -1. So this is going to factor as e to the x minus 2 times e to the x minus 1. Once it's factored, just like any other quadratic equation, to finish solving, you're going to set each one of those factors equal to 0. Now in each of those factors, follow your rules for solving an exponential equation. We want to get the exponential all by itself. E to the x equals 2. And e to the x equals 1. Then we want to take the natural log of both sides when we're in base e, and we take the natural log on the left side. That just leaves us with x equals the natural log of 2. The second one, natural log of both sides, we're left with x equals the natural log of 1. Plug each of those into your calculator. You get 0.693 and 0. So there's our exact solutions, natural log of 1 and natural log of 2. Approximations, 0.693 and 0. All right, when we're working things that aren't base E, doesn't matter. Okay, that is why we're going to use natural log, because it works for everything. So in this case, we have an exponential, 2 to the x equals 10. The exponential is all by itself. We're going to take the natural log of both sides. Use your properties now. Not quite as nice as when it's an exponential involving e because the stuff just doesn't cancel, but still pretty easy. If we use our power or our rules here of properties of exponents or properties of logarithms, when I have an exponent on an argument, I know I can move that out in front of the logarithmic expression. And now I'm solving for x. How do I get x by itself? Well, I divide by the natural log of 2. There's our exact solution. Go ahead and plug that into your calculator. Natural log of 10 divided by natural log of 2. 3.322. Both exact solution and decimal solution need to be given. Letter B. This time we have multiple exponentials, so we isolate one of them. Well, one of them already is isolated. Once they're isolated, we take the natural log of both sides. Reason we take natural log of both sides is because now our property of logarithms allows us to pull the exponents out front. There's a common mistake that's going to be made when you have a binomial or even trinomial or whatever it might be. Make sure when you pull that out front that you are putting that in parentheses. If you don't, you're going to forget to distribute. You're going to get the problem wrong. On the right side, we just pull the x out front. And now keep in mind you are solving for x. Well, on the left side, we have a distribution to simplify. We get x natural log 4 plus 3 natural log 4 equals x natural log 7. From here, we want to get everything with x on one side, everything that doesn't have x on the other. Since I have x's on the right only, let's move this x natural log 4 over with it. So on the left, I'm just left with 3 natural log 4. On the right, x natural log 7 minus x natural log 4. We're trying to solve for x. So how can I get that x out of that right side so I can solve for it? Well, both of those terms have in common an x. So on the left side, or right side, we can pull an x out, which leaves us with natural log 7 minus natural log 4. And now we can solve for x. We end up with 3 natural log 4 over natural log 7 minus natural log 4. And now plug that into your calculator. When you plug that in, make sure you are using parentheses property. A lot of people are going to miss points on this upcoming test because you're going to be able to get to the exact solution, and when you go to give me the decimal approximation, you're going to put something into your calculator wrong as far as parentheses. Get used to always grouping the numerator together. 3 natural log 4, close the argument in numerator. Divided by, group the denominator together. Natural log 7, close the argument, minus natural log 4, close the argument, and denominator, hit equals. You should get 7.432. Last one here, number 4. Same type of thing. We have multiple exponentials. Isolate either one of them. They're both isolated in this case, so go right to step 2 and take the natural log of both sides. Use your properties of logarithms that allow you to pull now that exponent out front. Both are binomial factors. Don't forget to put them in parentheses so you remember to distribute. Simplify. We get x natural log 5 plus 2 natural log 5 equals 2x natural log 3 minus natural log 3. Solving for x, so we want everything with an x on one side, everything that doesn't have an x on the other side. So we're dealing with the least amount of negative things as possible. I'm going to add the natural log 3 over to the left side and leave everything then without x's on this side. And I'm going to subtract the x natural log 5 over to the other side. Trying to solve for x. So now on that right side, we can pull an x out of everything, which leaves us with 2 natural log 3 minus natural log 5. Finish solving for x by dividing, and there's our exact solution. 2 natural log 5 plus natural log 3 divided by 2 natural log 3 minus natural log 5. Plug all that into your calculator. Again, when you plug it in, make sure you are grouping numerator and denominator together. So up top, we have 2 natural log 5, close the argument, plus natural log 3, close the argument and numerator, divided by, group the denominator together, 2 natural log 3, close the argument, minus natural log 5, close the argument and denominator, should get 7.345. Both exact solution and decimal approximation.